This is CPM Precalculus Chapter 1, number 135. So we're asked to solve for x, and we're given the equation x squared plus b equals to 7. Okay, so this we can see is a squared term, this b is some constant number, and 7 is a constant number as well. Okay, so how do we do this? Well, one way we could do it is using our quadratic formula, right? We want to first, so let's do this in two methods. Let's first use our quadratic formula. Okay, so to use this, we have to set this equation equal to 0. So it's going to be x squared plus b. So if we subtract 7 from both sides, we get it equal to 0. Because 7 minus 7 here is 0. And this, we subtract 7, and we write it right there. Okay, so once we have this, what are our a, b, and c values for our quadratic formula, being x equals to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so we know a is in front of the x squared, right? And the coefficient is 1. We know b is in front of the x term. So this is going to confuse you, or they're trying to confuse you by just labeling it as a b. If you're thinking about quadratic formulas, because we know that we do not have an x term here. So if we were to add an x term, it would be 0 times x. Okay, and this whole thing here is our constant term, right? It's constant. Because b isn't being multiplied by x, it's just b. So it could be 32, it could be 15, but it's just going to be a number, not times x. Okay? So once we get a, b, and c, we can plug them in. Negative b, well, we have to use this b. Negative 0 plus or minus, again, b squared is 0 squared minus 4 times a is 1. And c is b minus 7. And divide that all by 2 times 1. Okay, so let's simplify this. Well, 0, negative 0 is just 0, so we just have plus or minus. 0 squared is again just 0, so we have negative 4 times b minus 7 over 2, right? Well, let's see. What can we do? Well, we know that we have a 4 on the outside of this parentheses, so we know that this is the same thing as plus or minus. We could break, since these are being multiplied, right? We could break the square root up and say square root of negative 4 times square root of b minus 7 all over 2. And why am I doing this? Because we are able to do that one more time. So square root of, what is the square root of negative 4? Well, that's the same thing as negative 1 times square root of 4, right? Times square root of b minus 7. Okay, I'm going to just break them up like that, just so we can see how this simplifies. Because square root of 4 we know is 2, right? So plus or minus, let's say square root of negative 1 times 2 now. We no longer square root it because we took the square root, b minus 7 over 2. And because these are all being multiplied in the numerator, we can cancel the 2's and we just get plus or minus square root of negative 1 times the square root of b minus 7. Okay? And just like we took them apart earlier, we can put them all under the same square root, and this will be just negative 1 times b minus 7. Okay? And then we can distribute the negative 1 in. So if we distribute the negative 1 in, we get square root of negative b, and then minus, well, the negative and the negative cancel out, so plus 7, right? Or we could write this as plus or minus square root of 7 minus b. And I'm just subtracting them to make it look a little nicer, okay? And one special asterisk here, a very important asterisk, is that, well, we know that for this to be a real number, right, not imaginary, then we know 7 minus b has to be what? Has to be greater than or equal to 0. Because if it's negative, we have imaginary numbers. So let's just quickly solve this for b. Let's subtract 7 from both sides. We get negative b is greater than or equal to negative 7. And if we divide both sides by negative 1, we get b. And since we multiplied or divided by a negative, we have to switch the direction. Is going to be less than or equal to 7. Okay, so for this to be real, b has to be less than or equal to 7. But this is our value of x right here, and this is our big asterisk, right? B has to be less than or equal to 7. Otherwise, our number is going to be imaginary. X is complex, right? With imaginary part. Okay, so that was one way of solving this problem. Let's quickly, because there's another one I said, let's quickly look at the other way. So this part showed us that we just found out was x is equal to plus or minus square root of 7 minus b, and then we had an asterisk. B is less than or equal to 7 for x to be real. Okay, so the other way to do this problem is going to be, oops, I just want to put this on the other side. So the other way is to just solve for it. So we have x squared plus b equals to 7. Well, we only have this term having an x. So if we move b over to the right, if we subtract b from both sides, we get x squared equals to 7 minus b. So how do we cancel out the squared? Well, what's the opposite of squaring? We know is to take the square root. If we do it on one side, we have to do it to both sides. So the square root is going to leave us with x, right? And since we square rooted x and it was squared before, it's going to be plus or minus square root of 7 minus b. And you see how this was a lot faster than doing it this way, right? Because we get the same answer. And then also, we know since we're doing the square root, we have the same asterisk, right? Important. B has to be less than or equal to 7. And if you forgot why, go check over here, right? For it to be real, what's under the square root has to be greater than or equal to 0. And we just solved that for b. B has to be less than or equal to 7 for x to be real. Okay, so you could do this problem using either method, this one or this one, and you can see that we get the same answer. Right here we get this answer, and here we get the same answer. All right, so this ends CPM Precalculus Chapter 1, number 135.